This is our physical science facilitator SS from Commodore Group of Schools. Welcome to the online classes. Children, in the last session we learned about some common salts. In that, we learned something about the table salts. When impurities are there, what is the color? Brown. What we call the rock salt. Rock salt. Okay, sometimes it is also being given as the coal. Okay, pigment coal we call. Now, let us see another common salt about NaOH, sodium hydroxide. Sodium hydroxide is also a common salt, base, a common salt. What is the other name of NaOH? Caustic soda. Let us see how we can get that NaOH. Commonly, this NaOH can be attained by one process called chlor-alkali process. Chlor-alkali process. A new word is there here, alkali. Alkali means base. When the bases are dissolved in water, when bases dissolves in water, then we can say those are alkali nature, basic in nature. Alkali. But all the bases may not dissolve in water. Once the question is given like this, BeOH taken twice. Beryllium hydroxide. Beryllium, secondary group element, valence is 2. BeOH taken twice. Beryllium hydroxide. The solubility of BeOH taken twice are nothing but beryllium hydroxide. In aqueous solution, the solubility is very less. Slightly it will dissolve. Means all the bases are not going to dissolve in water. But the bases which are dissolved in water, then what we call the bases? Alkali. Don't forget, half mark question. Alkali. Okay, so when bases are dissolved in water, then we can consider those bases are alkali. But don't forget, all the bases does not dissolve in water. The solubility of beryllium hydroxide is very less. Very less. Right? Now let us see how can we produce or how can we get NaOH. NaOH, sodium hydroxide, is a common salt. Commonly this can be attained by one process called like this, where NaCl, sodium chloride, table salt, where it's going to be the electrolysis. Electrolysis means, yes, by using of electricity we have to decompose the particular substance. Yes, by this electrolysis, when you did this electrolysis, NaCl aqueous solution. When NaCl dissolves in water, what solution is attained? Sodium chloride solution or salt solution. That salt solution is called as brine. Brine solution. Brine. Okay, remember that? So when NaCl dissolves in water, what we call the brine solution. Okay, all these will come under half marks. Because when you thoroughly read the textbook, then you will get the command of the textbook, then you can easily answer this half mark and 1 mark questions also. Now, this NaCl in aqueous solution, of course, dissolves in water. Then what happens? It will use NaOH, sodium hydroxide, and chlorine, and also hydrogen. Okay, so see here, how many chlorines are there? 2. Here only one chlorine is there, just keep 2 here. Now how many sodiums? 2 sodium, just keep 2 here now. Sodiums 2, but what about the hydrogens? Here 2, 4. Here only 2 is there, just keep 2 here. Now the equation is balanced. Okay, our problem is also balancing the reactions only. So, NaCl, when NaCl, sodium chloride, dissolves in water during electrolysis, what we call the solution? Brine solution. When it dissolves in water, it will use sodium hydroxide, chlorine, and also hydrogen. And this process is called as chlor-alkali process. Because in this process, first what I will take? NaCl salt in electrolysis. In this electrolysis, of course, electrolysis means cathode and anode will be there. One negative electron, one positive electron. Okay, so at anode you will get chlorine. At cathode you will get hydrogen, and very near of that you will get sodium hydroxide also. Sodium hydroxide also. So it is a very useful process. Very useful process because here you are getting hydrogen, chlorine and sodium hydroxide. In a single space, in a single process, we are attaining three different substances, and these three are also very important substances. Very important. Hydrogen can be used as a fuel and in the production of ammonia. Why ammonia? For fertilizers. Okay, so hydrogen can be used as a fuel. And of course, for the preparation of ammonia, which is used in fertilizers. And chlorine very much useful. Chlorine is very much useful as preparation of bleaching powder. If you want to get the bleaching powder, we need chlorine. And the preparation of hydrochloric acid, HCl. And of course, in swimming pools and also PVC, polyvinyl chlorides. Polyvinyl chloride pipes, PVC pipes are there, no? The PVC pipes. Okay, and it's a cleaning agent in swimming pools and disinfecting agent of different water tankers. So, plenty of uses are there with the help of chlorine, for the chlorination of water. So, it will kill the germs. And NaOH, sodium hydroxide, caustic soda itself, it is a base, it is used in different. So, in this chlor-alkyl process, we are getting different substances. Of course, when you add these two also, you get directly HCl, hydrogen is there, chlorine is there. So, chlor-alkyl process is a very useful process where we are extracting or where we are getting hydrogen at cathode, chlorine at anode. Don't forget, during this chlor-alkyl process, dash gas is evolved at cathode. Which gas is evolved at cathode? Hydrogen gas is evolved. At anode, chlorine. Which flakes are going to be attained at the cathode? Sodium hydroxide. Sodium hydroxide. So in this chlor-alkyl process, we are getting different substances at a single process. Have understood? First, what we have to do here? Sodium chloride. Sodium chloride. Sodium chloride we have to take as an aqueous solution. And during this electrolysis, the NaCl dissolves in water. What we call that solution? Brine solution. During this electrolysis, at anode, chlorine gas, at cathode, hydrogen gas is evolved, and this flakes of the sodium hydroxide is also going to present very near of the cathode. So this is called as chlor-alkyl process. Chlor-alkyl process. Okay, don't forget about this important one because we are attaining different substances. Okay, understood? So, chlor-alkyl process, first I will take NaCl. So many bits are there here. NaCl in water, what do you call that? Brine solution. At anode, chlorine gas is attacked. At cathode, hydrogen gas is attacked. This chloride very much useful in the preparation of PVC, especially PVC, polyvinyl chloride. Right? Okay. So next one, another common salt is about bleaching powder. Bleaching powder. What is the color of bleaching powder right now? Bleaching powder. What is the chemical formula of this stuff? CaOCl. Ca, calcium oxychloride. Calcium oxychloride is called bleaching powder. Bleaching powder. Let us see how we can get this bleaching powder. What is the chemical process to attain this bleaching powder? Very easy process. Already you know about chlor-alkyl process. So when you take the NaCl, during this electrolysis, chlorine gas is evolved. Chlorine gas is evolved at anode. That chlorine gas has treated in the presence of calcium hydroxide. or it's going to be combined. It's going to combine with the calcium hydroxide. But don't forget, the calcium hydroxide you are going to take here should be dry. Dry calcium hydroxide you have to take. Means, what are the requirements for us? So, previously we have taken chlorine gas. So, the chlorine gas, chlorine slightly yellow in color. So, that is the reason when HCl is added or maybe chlorine is added to the water, slightly it will convert into pale yellow in color. Light yellow, just like mustard color. Okay, slightly yellow in color. Right. So, when this chlorine is going to be treated with who? Calcium hydroxide. Calcium hydroxide. What type of calcium hydroxide? Dry calcium hydroxide you have to take. When this chlorine is going to react with calcium hydroxide, the dry calcium hydroxide, then you can get bleaching powder, CaOCl2, bleaching powder. Of course, water will also form. It's about the equation. Calcium hydroxide. The calcium hydroxide is react with chlorine. Okay, don't forget the condition here. Dry calcium hydroxide you have to take. If you take the vector, the reaction will not consent properly. Okay, so it's about the preparation of bleaching powder. Very important for mark. There will be asking different things. Once the question is given like this, there is a compound X. There is a compound X is formed during the treatment of dry calcium hydroxide with chlorine. There is a compound X which is prepared, which is formed by the treatment of dry calcium hydroxide with chlorine. What is X? Calcium oxychloride. So you should know what happens when this reaction is going to take place. Otherwise the question may be asked like this. Dry calcium hydroxide is treated with X. Dry calcium hydroxide treated with X and attain bleaching powder. Then what is X? You will go for the chlorine. So if you know the equation, that however the question is going to be asked, you can easily analyze it. Have you understood how the bleaching powder is going to prepare? Okay, so dry calcium hydroxide and chlorine, the bleaching powder is applied. Now, uses of bleaching powder. Okay, children, uses. Given a very little about the uses of bleaching powder. Of course, nowadays bleaching powder is very demand due to this corona effect now. Okay, so why bleaching powder? What is there in the bleaching powder? Chlorine is there. Chlorine has the capacity to kill the germs. Okay, right. Now this uses, to remember these uses, I will give some keywords. Keywords like this: paper, cloth, agent. Paper, cloth, agent. Where? In water or in chloroform. Okay, so remember these keywords. Okay, from these keywords you can identify and you can easily write the uses. So totally 5 uses are there. We will write those one. First point, first use. What is that? Paper. Paper means paper industry. In paper industry, bleaching powder is used as cleaning agent. It is used as cleaning agent. Of who? Is wooden pulp. To clean the wooden pulp. Okay, wooden pulp. So cleaning agent. So this bleaching powder is used as the cleaning agent. Where? In paper industry, to clean the wooden pulp. Of course, paper is obtained from trees only, no, wooden pulp. So we have to take that wooden pulp and it has to be treated with bleaching powder as the cleaning agent. Different types of qualities of papers can be added in the treatment of bleaching powder. So bleaching powder is used as the cleaning agent of wooden pulp. Where? In paper industry. In paper industry. So first point is over. Okay, first is about what are the keywords? Paper cloth agent, water or chloroform. Paper cloth. So second point is about cloth. There also bleaching powder is used. Bleaching powder is used. What purpose? To clean the cloths in laundry. In laundry. Cloths. Okay, so if you want to clean the cloths, better to have what we call this bleaching powder. So we are using bleaching powder in where? Laundry also to clean that one. Next one, agent. This calcium oxychloride is going to be used in different industries. In different industries as an oxidizing agent. Oxidizing agent. So bleaching powder is used as an oxidizing agent in different industries. Why oxidizing agent? Because the bleaching powder is having oxygen, single oxygen. Single oxygens are called nascent oxygens. Okay, single oxygen, nascent oxygen. This nascent oxygen is going to be used as an oxidizing agent in different industries. Of course, in higher classes you will learn more about this nascent oxygen. Clear? So third point, what is third point? Bleaching powder is used as an oxidizing agent in different industries. Of course, the next one, fourth one is about water. So bleaching powder is used in purifying the water. Purifying the water. For what purpose? To kill the germs. Harmful germs are there in water now. Of course, some of the drainage also. You may see very near of the drainage, they are going to pour the bleaching powder. Because harmful germs are there. In that. That harmful germs are going to be killed. The harmful germs are going to be killed by using of this bleaching powder. The same thing in the drinking water also, the water treatment. In water treatment, bleaching powder is going to be added to the water. Of course, when you are going to Tirumala, just beside of the water pack, so plenty of water is going to present when you observe the smell of the slight smell, bleaching powder smell is going to be present in that water because it has been treated with bleaching powder. Of course, when you move towards that river, in that way you can have the huge water purifying plant is there. Then you can see what the bleaching powder is there and after chlorine is there. They are going to be treated with the different stages. So there they are going to use calcium oxychloride, nothing but bleaching powder. When they are going to add the bleaching powder, then germs are going to be killed. When the germs are killed, we will be safe. So in the purification of water, we are using bleaching powder. What we call that? Disinfecting of water we call generally. What purpose? To kill the germs. Next one is chloroform. So bleaching powder is used. Bleaching powder is used in the manufacture of chloroform. In the manufacture of chloroform. Don't forget CHCl3. Formula is important for us. CHCl3. What is the chloroform formula? CHCl3. Chloroform. Why we need the chloroform? Commonly they say, what is chloroform? In movies, if the villain is going to kidnap the heroine or somebody, they will take the kerchief and they will add some solution and they will keep at the nose and slap. That solution is called as chloroform. Okay, which easily considered or break, the person is going to be asleep. Okay. Right. So chloroform. So the manufacturer of chloroform also we are using bleaching powder. Bleaching powder. Of course, commonly in olden days the dissections are going to be done in the presence of chloroforms. As the BPC students, of course, nowadays we are not having that one. Have understood what are the units totally? Of course, they given us the 4, but we split into 5. What are the keywords? Paper cloth agent, water chloroform. Okay, so paper industry to clean the wooden color, cloth in laundry to clean the cloths. Agent, what type of agent? Oxidizing agent, because single oxygen is the what we call the nascent oxygen. Now, water, in water treatment we are using this bleaching powder to kill the germs or the purification of water. Chloroform, bleaching powder is used to create or to form, to get chloroform. It's about bleaching powder. Okay, what is the formula of bleaching powder? CaOCl. What is the chemical name? Calcium oxychloride. Children, do one thing. After finishing this lesson, take a paper and form a gist. Serial number, chemical name, carbon name, formula. So like that, so when you prepare a chart, when you are going to see them, immediately they can be recognized in your brain. Less time, more effectively you can present in your examination. Okay? So prepare a gist like that. Serial number, chemical name, carbon name, and formula. So here bleaching powder is the common name. Calcium oxychloride is the chemical name. CaOCl is the formula. So like that you have to prepare one chart. After this, after the bleaching powder, we are having one more common salt, that is NaHCO2. Sodium bicarbonate or sodium hydrogen carbonate. Both are same. Sodium bicarbonate or sodium hydrogen carbonate. Let us see how we can identify and how we can prepare this sodium bicarbonate. Sodium bicarbonate. For that, okay, so have to go for the equation. First, NaCl, sodium chloride, will be treated in the presence of carbon dioxide and of course water and of course ammonia. So, like this, so many chemicals are going to be combined with each other. Sodium chloride, carbon dioxide, water and ammonia. Of course, ammonia slightly basic in nature, carbon dioxide slightly acidic in nature, NaCl and water are neutral. All these chemicals are going to combine. All these chemicals are going to be combined and they will form two salts. That is about NH4Cl, ammonium chloride, and besides this, sodium bicarbonate. Sodium bicarbonate. See here, how many hydrogens? 3 and 2, 5. Here 4 and 1, 5. Sodium 1 and 1. Chlorine 1, 1. Carbon 1, 1. Oxygen 2, of course 2 here and 1 here. So, equation is already balanced. So, if you want to get the sodium bicarbonate, if you want to create the sodium bicarbonate, you have to treat the sodium chloride with a slight acid and a slight base. Slight acid and slight base in aqueous. So, NaCl, water, base of ammonia, acid of carbon dioxide are going to be treated along all these. You are going to get ammonium chloride and sodium bicarbonate, two important salts. Among this is a common salt, sodium bicarbonate. What is the common name of sodium bicarbonate? Yes, very good. Baking soda. Baking soda. Okay. So, understood. Now let us see what is the uses of the sodium bicarbonate and a special use of the sodium bicarbonate, that is about baking soda. Baking soda. Baking means is cooking. Okay. So, but in bakeries we are using this sodium bicarbonate. We are using the sodium bicarbonate in bakeries The question is going to be asked like this. After adding this baking powder, don't forget baking powder. I am not going to say baking soda. Baking powder. When baking powder is added to whom? Bread. Okay, bread in the bakeries, in cakes. When baking powder, not soda. Baking soda is different from baking powder. Okay, don't get confused. Most of the children are going to be confused during this half-bar questions. Sodium bicarbonate, baking soda. Baking powder is different from that one. Let us see how we can get the baking powder also. But the question is going to be asked like this. After adding what? Baking powder. After adding baking powder, the cakes and maybe the bread will become soft and spongy. Soft and spongy. Why it is going to happen? Very easy process, already you learned that. But apply that knowledge, that's all. Sodium bicarbonate is there. Sodium bicarbonate. What do you call this? Is sodium bicarbonate, baking soda. Baking soda. When this baking soda is combined with a mild acidic nature, anything mild acid, most probably you are going to take one acid which attained from tamarind solution. Now remember, already asked, again we are going to use this word, tamarind. What is the acid present in tamarind? Tartaric acid. Tartaric acid. C4H6O6. Tartaric acid. Tartaric acid. Then, when the sodium bicarbonate is treated with a mild acid, then you will get one powder. That powder is called as baking powder. Baking powder. So baking powder is the combination of baking soda and mild acid. Baking powder is the combination of baking soda and mild acid. When these two are going to combine, then you will get baking powder. How this baking powder is going to make that substances soft and spongy? Let us see here. What is this one? Bicarbonate. Bicarbonate is going to treat it with whom? Acid. Remember chemical equations of acids? I said when acids are combined with carbonates or bicarbonates, what gas is evolved? What is the gas? Carbon dioxide gas. Clear, children? Just once you remember. When acids are combined with metals, hydrogen gas is evolved. When acids are combined with carbonates or bicarbonates, carbon dioxide gas is evolved. That carbon dioxide treated with calcium hydroxide converts into slate line as layers, milky white layers. How remember? Yes. So here what we are using? Bicarbonate. Bicarbonate is going to react with whom? Acids. So when bicarbonates are reacted with acid, immediately what happened? Carbon dioxide gas is evolved. Carbon dioxide gas is evolved. So when you are adding baking powder, two uses are there: baking soda and baking powder. Baking soda will also faster the cooking. Okay, it will reduce the span of the time. So less fuel can be used. So baking powder will also do the one, baking soda also will do. But baking soda is unable to make the substances soft and spongy. Baking soda. But baking powder is having the capacity, especially the bakeries, bakery items, they have to be very spongy, soft and spongy now. For that purpose, they are going to add baking powder. Baking powder. What is baking powder? The combination of baking soda and mild acid, most probably tartaric acid. One more thing. There is no formula in the textbook for tartaric acid, but once it is given, the formula of tartaric acid also. What is the tartaric acid formula? C4H6O6. The tartaric acid formula. Right. Sodium bicarbonate. Sodium bicarbonate is treated with acid and carbon dioxide is released. The released carbon dioxide will make the substances soft and spongy. The bakery items are soft and spongy because the evolution or the release of carbon dioxide. So the carbon dioxide release that makes the substances soft and spongy. Okay, don't forget 2 more question. How the bakery items are so soft and spongy? Because they are going to add baking powder. When this baking powder is nothing but the combination of sodium bicarbonate, baking soda and tartaric acid. So when bicarbonates are added with the acids, immediately carbon dioxide gas is released. That released carbon dioxide will make the substances or the bakery items soft and spongy. Okay, clear now? Right. So sodium bicarbonate. And the uses of this sodium bicarbonate. Sodium bicarbonate is used as a fire extinguisher. Because carbon dioxide, CO2 is the best fire extinguisher now. If you take sodium bicarbonate, NaHCO2, it's going to be used as a sulfuric acid, the presence of sulfuric acid. You know what CO2 cylinders in schools also you can observe. Fire extinguisher cylinders. In that, the fire extinguisher cylinders, that will be like this, no cylinder. In that, one test tube or boiling tube will be there. In this, they are going to take H2SO4, sulfuric acid, and remaining is about sodium bicarbonate. Once you need, of course, pipeline will be there like this, one pipe. If when fire accidents are heat evacuation, what happens? They will invert it and press. Then this tube will break. It's a test tube or boiling tube, no? It will break down. So what is there here? Sodium bicarbonate is there, NaHCO3 is there. What is there in this test tube? Sulfuric acid. So reaction takes place these two. It is a bicarbonate and acid. When bicarbonates react with acids, very good, carbon dioxide, gas is evolved, of course, water will form and salt. Na2SO4. So like this, but forget about this, what we need? CO2 is needed. Because CO2 is the best fire extinguisher, irrespective of the cases. If you take water also fire extinguisher, but during electric short circuits you should not use that one. And when it's going to happen because with the presence of maybe fuels, just like diesel or petrol, in that time also you should not use that water. Because the density of water is more, it will go down and petrol will float on the surface of them and it's going to be continuously burned. Okay, so but carbon dioxide can be used irrespective of the causes. Okay, so carbon dioxide is the best fire extinguisher. So sodium bicarbonate is used as the fire extinguisher because it can produce the carbon dioxide. And not only that, for the production of sodium carbonates also. If you want to get the sodium carbonates also we can use to produce sodium carbonates. What is the first point? As the fire extinguisher. As the fire extinguisher we are using the sodium bicarbonate. And second one is about to produce sodium carbonate. Washing soda to produce the sodium carbonate also. And one more thing. Already I told you about that. What is the acid present in the honeybee stings? HCO1H, correct? Formic acid is there. So to get relief from that burning sensation, what we are using? NaHCO3. So sodium bicarbonate is used to get the relief from those things. Okay, maybe redux or honeybee is getting by. At that element we are going to be used. Element means the place where we are suffering. Okay, so there we are going to apply this sodium bicarbonate to get relief because it is mild base. It is about mild base and non-corrosive also. Mild base and non-corrosive. So that we are using, okay, to get relief from that one. Besides this, already I told you that to reduce the span of the cooking time. The time span is going to be reduced by using cooking. What do you call it? Soda or powder? We can use the both, right? So baking soda can reduce the span of the cooking time. So those are the uses of baking. Correct. Now we will go for the sodium carbonate. So what is the other name of sodium carbonate? Washing soda. Already I told you that how we can identify, how can you get that sodium carbonate. Sodium carbonate can be attained by sodium bicarbonate. So when you heated this one, sodium bicarbonate, NaHCO3, when you are going to heat at a particular temperature, then you will get right. Then you will get sodium carbonate. Okay, besides this sodium and carbonate, besides this, of course, you will get water. Some water also will be formed. So if you want to get the sodium carbonate, nothing but washing soda, what do we need? Baking soda. We will get washing soda from baking soda or heating. This can be used. Uses of sodium carbonate. Of course, first point itself is called as washing soda. And for washing of clothes. We are using this one. And of course, commonly Na2CO3 will be right, but the original formula of this one is Na2CO3 of 10 water molecules. 10 water molecules are going to present in it. We will see what is this water molecules and what we call that in an activity also. So for washing purpose we are using, and for creation of the creation of borax. You know about the borax? Okay, you know very well about the borax powder. Commonly we are going to use borax. You know about the borax powder to clean the woods we are going to be used. Okay? We are going to be used that one, right? Next we will see one activity about crystallization of water. Of course, it is used in the domestic purpose and as the fire extinguisher. It is also non-corrosive and by basic nature. Okay, so once go through the textbook for the uses of all the salts. Let us see, very important, very important. And already I told you that two chemical activities are very important in this chapter. About that, reaction of acids with metals. Next about crystallization. Now we are going to discuss about crystallization activity. Okay, so let us go for the crystallization activity. Okay, see what are the requirements and all those things we will see. Yes. Okay, children. So the last topic of this acids and bases, crystallization of water. Very important concept, very important activity for 4 marks. Okay, so first let us see what is crystallization of water. Crystallization of water can be defined as the fixed number of water molecules chemically attached to each formula unit. One formula unit is 1 mole of a salt. You are having different salts. Yes, like this, we take Na2CO3, sodium carbonate, that is what washing soda, which is having 10 water molecules along with. When you go for Epsom salt, MgSO4, 7H2O. When you go for that copper sulfate, CuSO4, 5H2O. Carbonate, MgCl2, KCl, 6H2O. Or maybe gypsum, CaSO4, 2H2O. From all these, what do you observe here? Water molecules are there. So it is about 1 mole of salt. 1 mole of sodium carbonate, 1 mole of magnesium sulfate, 1 mole of copper sulfate, 1 mole of calcium sulfate, 1 mole of MgCl2, KCl. 1 mole formula unit. Each formula unit of salt is having, what it is having? Water molecules attached to this formula unit. Here, 10 water molecules are attached to sodium carbonate, 7 water molecules are attached to magnesium sulfate, 5 water molecules are attached to copper sulfate. So, these are the crystallizations of water. All these salts are going to be the examples of crystallization of water. So, how we have to define this one? Don't forget, write an activity. Means directly we will go for it. Mostly the children can't analyze the question properly. First, the question will be given as define crystallization of water and write an activity. define crystallization of water and the right activity. So activity is that directly most of the children may go for a move apparatus chemical like this. But what is the question? Define crystallization. So first we have to define the crystallization. So many things are there like this. Define Ohm's law and activity. Okay, what is hybridization and explain the formations. So read the question properly whether the definition is being asked or not. In 33rd question also. What is a furnace? Rather your brain furnace. So like that. Read the question properly whether he is adding any other question to it. We should answer that one also. So for this crystallization of water definition, first we should know the definition of crystallization of water. What is that? Crystallization of water can be defined as the fixed number of water molecules. The fixed number of water molecules where chemically attached to each formula unit of a salt. You have to take a salt, unit salt. To that unit salt, number of water molecules are going to be attached. That what we call crystallization of water. Crystallization of water means number of water molecules that are attached to one formula unit of a salt. Clear the definition? Right. Now, let us see how we will do that one. For that, activity no? So, A. What is your A? To prove about crystallization of water. Crystallization of water. To prove the crystallization of water. That is our A. For that, what are the apparatus we need? The apparatus we need is about one dry test tube or maybe boiling tube. Dry. No water molecules or no moisture should be present in this one. So it should be dry. Dry. And one holder. And of course chemical. And substances we need is about one spirit lamp. So apparatus. These are the apparatus. What are the apparatus? Spirit lamp, dry boiling tube, holder. These are the apparatus. And chemicals we need. Chemicals we need is about copper sulfate. Copper sulfate and water. These are the chemical substances we need. Of course, in apparatus, matchbox. Matchbox also. Apparatus and chemicals are finished. What are the apparatus? Once again you will see. Boiling tube, yes, holder, spirit lamp, matchbox. Chemicals, copper sulfate, water. Now let us see the procedure. First, take a boiling tube. Take a boiling tube. In this boiling tube, take some copper sulfate salt. Here I am going to take some copper sulfate salt. What is that? Copper sulfate. What is the color of copper sulfate? Blue. Already I told you colors are very important for us. In matching they become. What is the color of copper sulfate? Is blue. So copper sulfate is there. Now we have to heat it. With the help of a spirit lamp. With the help of a spirit lamp, we have to heat it. Now, fire it up. So, of course, with the help of a holder. So when it's going to be heated, then you can observe one thing. Then we will go for the observation. Let us see what we are doing here. First, a boiling tube. Take a boiling tube. In that boiling tube, what I am going to take? Copper sulfate, CuSO4, of course, high water molecules. Copper sulfate. And hold it in a holder and keep on the surface of a spirit lamp, which is kind of fire. When gradually you are heating the salt, we can observe one thing, that the color of the copper sulfate, the color of the copper sulfate is changing. What is the color of copper sulfate? Blue. So when you gradually heating this one, the color changes. Is the blue color. The blue color of whom? Copper sulfate. The blue color of copper sulfate changes into white. The blue color changes into white. That is your observation. So then you go for observation. What is your observation? When you are heating, gradually the blue color copper sulfate changes into white. Why? At the same time, if you observe in the interior, in the inner walls of this, the inner walls of the boiling tube, you may observe water droplets. Water droplets means water molecules which are present in the copper sulfate, they get evaporated. Means they are separated from the copper sulfate. The water molecules are separated. You can observe the water droplets in the interior. Of course, we will do the activity, you can observe also. So copper sulfate, blue color will changes into white. That is an observation. Second observation, we can observe the water droplets on the surface of interior walls of the boiling tube. So when the water molecules are evaporated, the color of the copper sulfate changes into white from blue. Okay, so whether the color of the copper sulfate is only because of water molecules, how you are going to conclude that? For that purpose, now it became white now. For that white color, we have to add some water drops. When you add some water drops to the white color copper sulfate which is attained in this boiling tube, when this boiling tube will, what happen to it? It will changes into blue. The white color will change into blue by adding up water molecules. From this conclusion, from this above activity, I conclude that the color of the copper sulfate is due to presence of water molecules. Because water molecules are present in the salt. So that is called crystallization of salts or crystallization of water. Okay? Now we will go for that activity. Okay? Okay, children? Shall we go for that activity? So what are the apparatus we need? A test tube, holder, spirit lamp, matchbox. These are the apparatus. Okay. Then chemicals, water, copper sulfate. Procedure. What is the procedure? Take some copper sulfate salt in this test tube. Okay. What is the color of this one? Blue. I am going to take blue color copper sulfate to this certain amount of copper sulfate. Yes, I am going to take some copper sulfate in the test tube. Okay, so what is that color now? A little amount, very little amount of copper sulfate salt has taken this test tube. Now, we have to heat this one. How to heat this copper sulfate. For that purpose, we are using spirit lamp. Yes. It is a moderate process, it will take some time to convert. So, don't forget when you are going to heat, you should keep on the top surface, top layer of the stone. You may see that the changes which are, but don't forget the test tube should be dry. You should take the dry test tube. So, you may see the interior changes, the internal walls of that particular thing. You may see water droplets are going to present on the interior of the test tube, the inner walls. You may see closely. What is there? Water droplets are there now? Yes. Are you observing? So, water is going to evaporate. Water is going to evaporate and the color is going to changes. So gradually the color is going to change. So number of water molecules are going to present there, the test tube. So we are heating. It will take some time. Now we will see the color of that one. So see the bottom color, because all the water molecules are not going to be considered here. See that one. Are you able to see here? White color at the top. The top of this one is about white in color. White color means the blue color changes into white. Now let us see what happened when you add some water to it. Now I am going to add some water droplets to the particular copper sulfate. Just like white in color now at the top, I am going to add some water droplets to it. So drop wise I am adding water to it. Okay, so I am going to add some water to it. You can observe what is going to happen to this. I am going to add some water molecules now. So you may see the changing of the color. You may see the changing of the color here. Again it is changing into blue. Again changing into blue. Okay, so from this what you understood, the color of the copper sulfate. The color of the copper sulfate is due to presence of water molecules. When you add the water to it, again it changes into blue now. So previously blue in color, when you heat it becomes white, and again after adding it converts into blue. Okay, so the reason for the blue color of the copper sulfate is due to presence of water molecules. Okay, understood. So it is about the crystallization of what? Crystallization of water. Clear, children? It's about the lesson, and one small topic is that about plaster of Paris. The plaster of Paris, and of course the gist of this chapter will be given by the next class. Of course some homework is also given to you. All those things will be discussed by the next class, and it just enter the topic and how to cover different aspects and different academic standards which are come out of this chapter. Okay, have a question, children. Have a good day. Thank you.